the concept of expected value is a great tool with which we can make objective decisions. Now, as we approach these two examples, it's also important to point out that although we can figure out averages, it's crucial to also take into account what we feel is reasonable. Some of us prefer peace of mind, and we're willing to pay extra for that, regardless of whether or not there is some monetary profit. So in this first example, let's say that a pet owner brings his dog to the veterinarian for a checkup. The vet offers a pet health insurance plan that runs $25.99 per month. The plan only covers non-maintenance procedures like accidents, health conditions, treatments, surgery, etc. There is a $75 deductible that must be paid in the event that the insurance plan is used. So in other words, you pay the monthly fee, and if something happens, you have to pay this $75 deductible. Deductibles are often used in insurance plans to offset costs, as well as to discourage people from just unnecessarily going in because of every incident that occurs. So we often see forms of deductibles, although it's not quite a deductible, the idea of a copay is very similar. The insurance policy will cover one claim per year at most. After considering the last 5 years, he determined he had one large non-maintenance bill totaling $1,500 for his dog. If he feels this information is a roughly valid predictor of the future, does it make financial sense to invest in the insurance plan? What is the average annual profit or loss from this plan? So this is going to allow us to compute an expected value, though we need to keep in mind that the outcome of this is just a mathematical answer, and we need to decide whether the plan is worth it or not for that sake of peace of mind. Okay, so let's think about the random variable in this case. So we want to know the average annual profit or loss from this plan. So let's define a random variable x. And x will be the profit or loss from this plan to the owner. This is going to be different than what it is for the company, because the company is going to experience a series of varying bills, but we're assuming, based upon this person's last 5-year experience, that he'll only have one $1,500 expense. Now, will that be true? Probably not, but we have data, and from that data we want to try and make a decision. So what are the possible outcomes? With an insurance policy like this, there's really only two possible outcomes. He files a claim for his dog, or he doesn't file a claim for his dog. So let's look at the values of x. Notice that we haven't listed them out here because we need to do some calculation. And we mentioned that there are two possible outcomes. There's the outcome where he does file a claim and where he does not file a claim. Let's look at the situation where he files no claim first. So in terms of what profit or loss he'll make from the plan, first of all, this is a monthly rate, and our unit of time is over a 5-year period. So if we think about the fact that we want an annual profit or loss from this plan, we should get everything into 1 year at a time. So if there is no claim filed, then he will have paid $25.99, so that comes out of his pocket per 1 month for a 12-month period. So again, we're looking at this for an annual profit or loss. And so we need to figure out what is $25.99 times 12. That comes out to a loss of $311.88. Okay, now that's just under the situation of no claim. We have an X value of negative 311.88. Okay, so that's one of our values, is negative 311.88. In any year, he may simply lose that much. But if he files a claim, now he's still going to have to pay the monthly premium all year long. He's still going to have to pay out the $311.88. He's also going to have to pay the $75 deductible because he's filing a claim. And it says that must be paid in the event that the insurance plan is used. He's going to also pay $75, but he's getting a benefit now. And assuming that this value is a predictor of the future, the insurance company is basically going to give him $1,500 with which he could pay the veterinarian. So in other words, they'll pay the bill for him. So if we add these up, 1,500 minus 75 minus 311.88, this is a benefit of $1,113.12. So the way we could look at it is in any given year, he may either benefit $1,113.12 or be out the $311.88 that he spent. Now, as far as the probability goes, the probability that he files a claim, we know it's once in a 5-year period. So one claim in 5-year period. And so if that is a valid indicator, then there is a 1/5 chance in any given year. All right, one of those 5 years represents 1/5 of the time. There's a 20% chance in any given year, so 1 out of every 5, that a claim will be filed. Well, that must mean then if these are going to add up to 100% of the time, he's not going to file a claim 80% of the time. And we have enough to compute our expected value. Now, again, our expected value is a profit or loss, which is going to be in dollars. And this is over a 1-year period, so this will be dollars per year. Dollars per year. Okay, so our expected value, oh, and then our other value here, of course, is that $1,113.12. And the expected value of this random variable is the probability of a claim times the value of that claim, plus the probability of no claim times the value of, oh, I've mixed those up. This should be 1113.12 plus the probability of no claim times the outcome, the numerical outcome of that event. Okay. Now we can see that the high severity occurs with low frequency, but the low severity occurs with high frequency. Most years we're not going to file a claim. And so 0.2 times 1113.12 plus 0.8 times negative 311.88 comes out to negative $26.88 per 1 year. So this is a loss on average each year. That's a loss of $26.88. This is assuming that in one 5-year period in the future, he will only spend $1,500. So whether or not we say, well, we're not going to buy the insurance plan because there's a loss on it, is really contingent upon, is $1,500 over 5 years reasonable? And even if it is paying this extra $26.88 per year is that beneficial to some sort of peace of mind? So I just want to kind of point out the balance between what the mathematical answer says and then what practical approach we want to take towards actually analyzing. Let's now take a look at a hotel. And the hotel has 100 rooms, each room costing $130 per night. Historically, Friday nights have always been sold out. In some cases, reservations are made by guests, but they do not show up and it's too late for a refund. So the hotel chooses to overbook rooms and make reservations for 104 rooms. The probability that one reservation results in a no-show is 30%. So they have 100 rooms, but they make 104 reservations. And then there's a certain likelihood that one of those 104 reservations will not appear to claim it. The probability that 2 reservations result in no-shows is 15%, 3 reservations is 8%, and 4 is 5%. If a guest shows up and the reservation has been taken by one of the overbookings, the hotel immediately refunds the cost of the room and gives a voucher for 1 free night. On average, will the hotel make profit from this plan? So our random variable in this case is the profit in dollars made by overbooking a Friday night. Well, this profit is going to vary depending on how many no-shows there are. Now, because we've only been given 1, 2, 3, and 4, we can assume that the probability that there are 0 no-shows is whatever percentage is left over when we subtract these away from 100%. So let's start off by analyzing the situation further. So we have certain profits, and then we have a probability of those profits. We need to consider the case where all 104 people show up, 103 people show up, 102 people show up, 101 people show up, and exactly 100 show up. Because we're making 4 overbookings, and we want to see, is there going to be profit on those? So we could have 0, 1, 2, 3, or 4 no-shows. Okay, no-show just means they don't show up. So let's think about what happens if there is a no-show. First of all, the benefit of overbooking is that they will collect an extra 4 reservations worth of $130 per night. So they will get $130 times 4 guests, and that's going to come out to $520 in benefit from overbooking. But of course, we know that the benefit may be outweighed by the cost. Right? So we have to do a cost analysis as well. This is what their revenue will be. So in each of these cases, they will collect $520. Let's analyze the situation in which there are 0 no-shows. So if there are 0 no-shows, then what that means is that 104 guests appear, and that means we have to pay out 4 what I'll call comps. They're going to have to comp 4 of those guests because they don't have rooms for them. So for each comp, they're going to, first of all, they're going to refund the cost of the room and give a voucher for 1 free night. So they're going to have to give back $130, and they are going to have to give a voucher, which is going to cost them another $130, right? Because even the voucher, that's a promise of a free night, and so that costs them money because that's going to take away on a future night from another guest that could pay for that room. So there are going to be 4 comps. It's going to cost us $130, another $130. It's going to cost $260 per 1 comp that they make. So if they make 4 comps, that's going to be 4 times negative 260, which is going to be $1,040. Right, so they collected $520 in those overbookings. They're going to have to refund all of that $520, but then they're also going to have to give 1 free night to each of those 4 guests. So even though they made $520, now they're actually going to end up losing $520. Right? The $520 that they collected for the 4 extra rooms, but now they lost the $520 and they lost an additional $520 for those 5 guests, for those 4 guests, because they had to give a free night. Now, if there's 1 no-show, that means there are 103 guests that arrive, which means they're going to have to give 3 comps, which is going to cost them 3 times negative 260. And 3 times negative 260 is negative 780. So this is going to cost them $780. So they still lost money. They didn't lose quite as much though. So now we have to subtract 780 from that. Right? So they're going to refund 3 people $130 and give them an extra $130 to come back and stay. And that's going to cost them $260 in net. Now, if we have 2 no-shows, well, that's 102 guests arrive. It's going to be 2 comps at $260 each, which means they're going to have to pay out $520 and they're going to break even, exactly even. Now, if they have 3 no-shows, they collect $520, that means 101 people show up, means they need to give 1 comp valued at $260. And so they're actually going to make an extra profit off of this scheme of $260. I shouldn't call it a scheme because businesses do it, since this is a way to take advantage of the fact that there might not be anybody. There might be people who don't show up. And then if there are 4 no-shows, well, that means they've collected the extra $520 because of bookings for 104 people, but exactly 100 guests show up, so they don't have nothing to pay out, and their profit is going to be $520. Now, the probability that there's 1 no-show, we know, is 30%. Probability of 2 no-shows is 15%. 3 no-shows is 8%, and 4 no-shows is 5%. Since these have to add up to 100%, we can figure out what the probability of all 104 guests showing up is by taking 1 minus 0.05 minus 0.08 minus 0.15 minus 0.3. So there's a 42% chance that all 104 guests show up. So that's not a really good sign, because that's a high frequency with a high severity. And if you look at it this way, well, 15% of the time they're breaking even, 8% they're getting 260, but 30% of the time they're losing 260. That already means we're going to come out at a loss. And then only 5% of the time are they gaining 520, but 42% of the time they're losing 520. So based upon these numbers alone, they're probably going to experience a loss because of this. So the average profit made on a Friday night, or a loss on a Friday, or we could call it a negative profit, will be 0.42 times negative 520 plus 0.3 times negative 260 plus 0.15 times 0 plus 0.08 times 260 plus 0.05 times 520. And when we do this, we get a loss of $249.60 per 1 Friday night. So every Friday night that we do this, well, in some cases we may have 4 no-shows, but and we may make 520, but because we're going to be losing money more often than we're going to be gaining money, this is actually detrimental. We're actually kind of forfeiting roughly 2 nights of free compensation when we're not actually making enough money off of these overbookings. So another possibility might be refund the cost of the room and give a voucher for $50 if really the end result that's desired is to make profit. But of course, is this a good idea even if you were making money? Well, it depends upon how much you want to value the individual customer and whether you want them to ever come back again. But anyway, mathematically, this would be the expected value, and this is just another application where it helps us come up with some quantitative information. Clearly, this isn't a good plan, so we may want to consider not doing this at all.